All right, so when we're converting back then from your rectangular to polar, we've got to do the r using your distance formula or your magnitude formula, your angle, by finding the inverse tangent of those values. My question to myself is, where is the tangent equal to -1? If you look at your chart or think about your chart, where is the tangent equal to +1? What reference angle? The 45 degree, which is your pi over 4. But what quadrant are we in? The fourth. So what's the pi over 4 in quadrant 4? 7 pi over 4. So you need to use the quadrant to tell you which one it's going to be. So to write that as an ordered pair in polar, what goes first, the r or the theta? The r goes first. So my answer to question 8 is root 2, 7 pi over 4. Okay. Now, if you don't come up with something that's in your chart, like you would in question 9, you will have to use your calculator to find your radian answer for this. So first I'm going to do my r, square root of, I just leave out the negatives because anytime you're squaring these things, it's just going to make them positive anyway. So I leave the negative out completely. Simplify the square root always. So in this case, when I do 5 squared plus 12 squared and square root that, anyone know what you get out? 13. Nice and even. To do my theta, I'm going to do the inverse tangent of what? -12 over -5. Quick mental check. What quadrant are we in? 3. When I do the inverse tangent in my calculator for this one, because clearly we should know there is no 12 over 5 in our chart. Your calculator needs to be in what mode? Radians, because that's what our angles are in. So, inverse tangent of -12 over -5. My calculator tells me that's 1.176. Is that my answer? No. That's the angle part of it, but that's not in the right quadrant. What quadrant is that in radians? That's 1. Okay, how do I know that? Pi over 2 is about 1.57. Pi is about 3.14, etc. So 1.176 is somewhere in here. If my angle is in third quadrant, how am I going to get the actual answer for this? Add that to pi. Use that as my reference angle, which gives me 4.318 as my radian. So to write my point, I'm going to write my r, then my radian. We prefer to have radians in terms of pi, but if you have to use your calculator, you're never going to get that back out. Okay. Let's try that again with question 10. First, what am I going to do to find my r value in question 10? Okay, square them both and put them under a square root. Okay, do I actually have to really do work for this one? No, because if I do 3.2 squared plus 0 squared and then square root what I squared, I'm just going to get 3.2 back out. Now, theta. This one, notice, does not say calculator, even though it's got those decimals. You're going to see why in a second. I'm going to do the inverse tangent of what over what? 0 over 3.2, which is just the inverse tangent of what? 0. So my question to myself is, where is the tangent equal to 0? Think about your chart. Tangent is 0 where? 0. 0. Pi, 2 pi. All right. Now, nothing. Someone else yelled something else, and I was trying to figure out. Now, this question right there, 3.20. Where is that? Because I can't ask what quadrant. It's on the x-axis to the right or to the left? To the right, 3.2. All right, so I have options for what I could use. I could use 3.2 and 0. I could use 3.2 and 2 pi. Why can I not use pi? Because that would be negative. Either one of those would be appropriate answers.
Whoa.
The only issue I can see with this one is that it's exactly the same as what you started with, and it's very difficult to see whether that's in X, Y, or polar. I would probably go with that one to be safe. But
Well, you can't go with pi because the 3.2 would be negative?
yes, because in X, Y coordinates, for us to go left, you'd have to go negative. Okay, same thing for number 11, last point conversion that we're going to do. Then we're going to do a little bit of equation conversion. So in this case, to get my r value, I'm going to do the square root of 0 squared plus negative 8 squared, or just 8 squared. What am I going to get for my r? 8. Again, this one is a non-calculator, and you're going to see why in just a second. When I do inverse tangent of y over x, I am doing the inverse tangent of what? Undefined. Yes, you need to recognize that that gives you undefined. So my question to myself is then, where is tangent undefined in my chart? Pi over 2, which means also where else? 3 pi over 2. Let's check where this point is before we use either one. 0, negative 8.
It's on the y-axis on the bottom.
So what's the angle we have to use?
It'd be negative pi over 2.
Or 3 pi over 2. Either one. All right, yes, you could use negative pi over 2 if you wanted to. You could use 3 pi over 2 if you wanted to. You could say negative 8 positive pi over 2. There's a lot of different ways to do that, so I'd have to check to see that your answer was appropriate. Any questions about converting x, y to polar? All right, flip over 2 pages. We're going to finish up with equations. Flip over 2 pages. It looks like this. We are finishing up converting equations from rectangular to polar, where rectangular is x, y, polar is your r and theta. There's a couple hints in this box here. Here are 2 conversions we can use. These right here, we used these equations to switch polar into xy points. Another equation you may use is replace any x squared plus y squared with r squared. When possible, solve your equation for r. Quick review. Anyone remember what this was?
Standard circle.
Circle. We did not do conics this year at all. Algebra 2. Remember, equation of a circle looked like this, where h and k was your center, and your radius was r. So if I was to graph this equation, what would be the center of that circle?
H and K.
Right. Is there an h and k in there? So that's going to be 0, 0 with a radius of what? The radius will be what? 6. All right, so if I was to graph that, look at your graph down here. All we had to do to graph that was put your center at 0, 0 and go out 6 on every side to draw a circle with radius 6. Right? And I am terrible at drawing circles, so you'll forgive my stupid one. All right. Now, to give you an idea of an equivalent expression in polar, there's multiple ways to go about this. Using the stuff that we had up there in the box, what's the easiest replacement I can make to switch this over to polar? X squared plus y squared is the same as r squared. If you did not have that, let me show you something else that will go back to Unit 8. What up in the box did we say we can replace x with?
R.
Okay. R cosine theta. and then x's squared. What can I replace y with?
Sorry.
R sine theta, and it's all what? Squared. If I square things out here, that's going to give me r squared cosine squared plus r squared sine squared. What's your common factor? R squared. Factor it out. What are you left with? Cosine squared plus sine squared, which we know from half of our last couple things that we've done. This is what? 1. It is 36. I just didn't finish writing. Sorry. So that's the same thing as r squared equals 36. So in polar, r squared equals 36. You can simplify that to what?
R equals 6.
R equals 6. That equation in polar is the same as this equation in rectangular. Because what this means in polar is your r equals 6 for every value of theta, or angle. So for every angle around your polar graph, your r is 6. So r equals any number by itself in polar means that you have, r equals any number means that you have a circle. That's a basic equation for polar. All right, flip to the back. We're going to do a couple more conversions here. Before we convert in question 2, what kind of equation is this? That's a flat line at -3. All right, so that is the rectangular equation. To convert it to polar, what's the only thing that I can replace there? Y. According to the box and the formulas that we used on the previous page, y is the same as what? R sine theta. The last thing in the box said, whenever possible, solve for what? R. So how do I get R by itself here?
No, sine.
You're going to divide your sine theta over here.
That's right. I thought it'd be inverse.
No.
No, not you.
So basic form, R equals a number divided by sine of theta is a horizontal line. Someone tell me, based off of that, what do you think a vertical line would look like? Cosine.
Wow.
R equals a number divided by cosine of theta is a vertical line. Because cosine has to do with your x's and sine has to do with your y's. Yeah, I know. It's a little nice. Isn't it? Yeah. There you go. On number 3.
This is very different because like you're not telling people to shut up.
Sometimes, a little bit, but not much. All right, this is another circle. I know, this is the rowdiest class we've ever had, probably.
I'll make this her least favorite box.
Yeah.
Great idea, Scott. I don't want to.
What's your center of your circle?
3, 0.
3, 0. What's your radius?
3.
3. The square root of the answer. So here's 3, 0. You go out 3 on any side. And you would get this circle-ish. Now, if I'd like to convert this, what do you have to do to this equation in order to do some conversions here? This one gets a little bit funky. Do I have any x squared plus y squared that I can replace right now? Not currently. So what could I do to get an x squared plus a y squared? Yes. All right. So here we got to do a little bit of algebra. I got to do x minus 3 times x minus 3, which gives me x squared minus 6x plus 9 plus y squared equals 9. Now, if I want to convert this to polar, I have to take out every x and every y. Easiest thing to do here to start with is what? X squared plus y squared is the same as?
Good.
R squared. So those change to R squared. The other thing that I have to replace is what?
X.
The x here. So I'm going to keep my minus 6. If you have to flip to the back page there, you can. What was the same as x?
Oh, R something. R sine theta.
R cosine theta plus 9 is equal to 9. What is my goal to solve for here? R. All right. So if I'd like to solve for R, how do I start? Minus 9, what's that going to do for me? Make 0. So I have R squared minus 6R cosine theta equals 0. You could take out an R. The easiest way for me to do this is to move this whole term to the right-hand side and divide by an R. If I divide everything by an R here, that makes it equal to R.
R is equal to 6R. Oh. Because it divides.
Yep. That's in terms of R's and thetas and cosines. Okay? Now, here's one other thing I'm going to show you with this real quick before we convert back. What if you had to graph this? You wouldn't be. Here. If you had to graph that and you don't know what that looks like, you make yourself a table of values. Okay? You are going to plug in thetas and get out R's. What are angles that I could plug in for that? I could plug in the angle 0. What else could I plug in? What would be easy ones?
1. -1.
What are angles in terms of radians? Pi over 2. What else? Pi. 3 pi over 2. 2 pi. I would probably stick with those. Why?
Because they're easy.
Because they're the easy ones. All right, so let's go through this real quick. If I'm plugging in theta equals 0 to get my R back out, that means I'm doing 6 cosine at 0. All right, so think about cosine at 0. What's the answer? 6. Because cosine at 0 is 1. How do you graph the point 0, 6 in polar? Or 6, 0, because you would flip that. The R is your first point. Where's the angle 0 in polar? On the x-axis, and then your radius is 6. So if you're on the x-axis, you would go out 6. Where would that be on this graph? Right here. We already had that point from our xy's.
So are those the same points?
They are the same points. It would look exactly the same in polar. What if I did 6 cosine at pi over 2? What is cosine at pi over 2? 0. So 6 times 0 gives me? Excuse me? 0. So at pi over 2, where's pi over 2 as an angle? Pi over 2 is up this way, but my radius is 0, so where's that point going to go? 0. Next, 6 cosine at pi. What's cosine at pi? Nope.
Oh, 1. No. 1.
Still haven't heard it yet. -1.
-6.
So that gives me -6. So if I want to graph the point -6 pi, Where's pi?
There.
Here. But -6 means I go which way?
That way.
Backwards.
That way.
So I land on the same point we had again.
Well, that's tricky.
And it would keep going around. You can get these points if you use the pi over 4s in my table. If I use the pi over 4s in my table, you'll get pi over 4 like out root 3 root 2, which would be out that direction. But you can get these same points by plugging in angles, thetas, to graph these. You can use these same conversions to go backwards from rectangular to polar, or to do more of those without graphing. Last one on this page is question 4. If I need to make replacements here, do I have an x squared first of all? No, and I'm not going to get one from this one, okay? Sometimes you just have to use your x's and y's. What can I replace y with? R sine theta, but the y is squared. What can I replace the x with? R cosine theta. I do have to kind of work this out a little bit. So what can I do here? Use your algebra. What can I do on the left? Well, you don't have to FOIL. It's just squared. R squared sine squared equals 2r cosine theta. My goal here, if at all possible, is to solve for what? R. All right, so what's one thing I can do from this one? First, I can divide by r, which gives me r sine squared equals 2 cosine. Then what am I trying to get by itself still? The r.
Divide by sine squared.
Okay, divide by sine squared. You can leave it like this. You can divide those if you want, but there's no point to doing it really. Some of these don't graph super nicely, which is why you don't see a graph with this one. Okay. Last thing we're doing is converting backwards. It uses the same rules, only it's a little bit weird on some of them. So on the next one, here's the thing with converting polar to rectangular. Almost everything that you have to switch out needs r to be squared, if at all possible. It's helpful to you. Like, for example, on this one, do I have anything in those equations that I can switch out a single r for? No. Do I have anything that I can switch out a single sign for? Not a sign by itself. I need an r with a sign, right? So here's what some things you can do with these to make it work. I need an r squared on the left, and I need another r on the right, right? What could I do to this equation? Multiply everything by r. That makes r squared on the left, 8r sine on the right. Now tell me what I can replace. R squared is the same as x squared plus y squared. R sine theta on the right is the same as y. Okay. Now, if I want to work backwards and turn this in, what is this going to be? Because of the x squared plus y squared? It's a circle. All right, we're digging way back for this one. Moving this to the left. Who remembers completing the square?
I remember doing it and not liking
You do
it.
x,
I remember.
and then you do
You take your b, divide by 2, and square it. What's -8 divided by 2 squared?
16.
16. If I add 16 here, where else do I have to add 16?
To the right.
To the right. Now all that's left to do here is factor it. What does y squared minus 8y plus 16 factor into? Y minus 4 squared. So this would be a circle with what center? 0, 4 with radius 4.
Wow.
Okay? I'm sure we do.
I like this first lesson.
I'm sure we do.
Oh yeah, graph report. That was fun.
We're almost done. 3 more questions. All right. 6. Look at your formulas. Is there anything to replace a theta with? No. What do I need there to replace the theta? A tangent. Is there anything preventing me from taking the tangent of both sides? What's the rule in algebra? If you do something to
Just do it.
one side, you have to do it to
Oh, yeah.
the other. So whatever you would like to do. All right. As long as I take the tangent of both sides, I am okay. Tangent of theta equals tangent at 11 pi over 6. Well, according to my formulas, what can I replace tangent of theta with? Y over x. From right here. What can I do on the right-hand side? Actually find the tangent of 11 pi over 6. Where do I get that? Your chart, not your calculator. So think about the tangent at pi over 6 in your chart, which is 1 over root 3, but in quadrant 4 it is negative. You may leave it here. When we are in rectangular, our goal is to solve for what? Y.
Isn't the tangent? I thought it was 6 root 3 over 2. I thought it was root 3. Oh, I guess that's the same thing as
It's the
1
same
over
thing.
root.
You can leave it this way. You can do root 3 over 3. I don't care. If I would like to solve for y, what's my last step? Multiply by x. What kind of equation is that? If I graphed it. That's just a line with a weird slope, but it's just a line. So if you ever in polar have theta equals an angle, those are actually really easy to graph because they're just the line along that angle, whatever it is. So you'd find 11 pi over 6 and you'd graph that line. That's it.
Oh, that.
Okay, so that's just the line. Last 2. On the back. Just like the first one, it is helpful for me if r is what? Squared. Well, the first one we multiplied by r both sides because we needed an r on the other side as well. It would not help me to have a single r next to a 2 on the right. So what's the other way we can get r squared? Square both sides. That gives me r squared is equal to what? 4. What's r squared the same as? Okay, now this one we're not going to solve for y because we know circles end up in this one. So we leave it. Yep. Yep. Now 8, last one. This is the first one that we've actually had to do some conversions with. What do I have to do some conversions with here? Secant. We don't like secant. What is secant the same as? 1 over cosine. Now, why does that help me to do that?
It's going to match up with our equation.
It's going to match up with our equations when I take my cosine and I do what with it?
Times it on each side.
Multiply it to the other side.
Times it out of 20.
Hey, I gotta think fast. Come on now.
All right, what is r cosine theta the same as? Hang on. What is that the same as? X. So what does this end up being? What kind of line? Vertical line. That's it. Done.